And hello. Today we'll be looking at lines and angles. So this is kind of our introductory lesson to geometry. So I suppose I should talk a little bit about what is geometry. And it all dates back to this guy, Euclid. And he has a very famous maths book called Euclid's Elements, where he kind of writes out everything to do with geometry. And what was really important at the time is he also provided proofs and axioms. So these are words you might have heard before, but they are very important in maths. Axioms are just things that we take as true. So an example would be the sea is blue. If you told a blind person a sea is blue, you just have to accept it. You might not be able to prove it, you might not be able to show people, but the sea is blue, that's just the truth. And we don't really have a way to prove it, but we just take it as true. So that's what an axiom is. A proof is using axioms or using different methods to show that something is true. So you'd be studying different proofs in the junior cert and leaving cert. But for now, just know that proofs are using steps and things that we already know to be true to prove something, to know that it's true. And famous mathematician, this guy Euclid, kind of formalized it. Before this, everybody was writing random things, but he's the guy that kind of came along and said, no, we gotta actually step by step prove that things are true. And he kind of started off with these kind of questions, like, what is a line? Now, I know all of us probably know already what a line is, but he came along and kind of formalized it, and particularly different definitions. So this is what we call a line segment. So a line segment is just a line that has a certain length. So in the real world, this is like a piece of string or a length of a road. It has a length. It has a start point and an end point, or two end points. And it has a length. So in this case, it's 4 centimeters. Then we have a line. Now this might be a bit confusing, but when we say a line in maths, usually we mean it's an infinite line. So see the way I have my arrows going off here, and there's 2 points A and B, but it keeps on going. So in a line in maths means it just goes on forever. It goes infinitely in this direction, infinitely in this direction. Then we have what we call a ray, which is an even more unique thing, where there's an end point here. So A is like a starting point, but then it just goes off infinitely in the other direction. So past B just keeps on going, it never stops. There's no end point over here. I could keep on going 100 meters, 1,000 meters, keep on going, it'll never stop. So you have to remember these kind of definitions. So a line segment, just think, okay, it has a length, it has 2 endpoints. A line goes off forever in both directions. And then this kind of weird one, a ray, where it has 1 point and then it goes off one endpoint and then it goes off infinitely in one direction. So then points. What do I mean by points? Well, points are plotted on a plane. So in this case, let's say on the screen, this is a plane. It's flat. It's 2D. So I'm just plotting points. I can plot going up here, 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 here. Now, obviously, I can't do 3D. That's a different definition. But in our case, we'll be talking about points in 2D. So on a screen, let's say, or a flat sheet of paper. And then points that are collinear are points, let's say if I drew a line going through these 3 points, well, they are collinear. Co, as in like together, linear, line, so like they're cooperating or they're together on the line. So collinear. So in this case, D is not collinear. Why? Because I can't draw a line that includes C, A, B. Like I could do like a zigzag thing, but I'm talking again, when we say lines, in most cases we mean straight line. It doesn't zigzag anywhere. Okay, well then we'll talk about angles. Now, I'm sure you already know what angles are, but we see them in everyday life. For example, let's say you might have seen this sign on the road, and there usually is actually a degree here. And this indicates how steep something is. So it tells you what that angle is there and how steep something is. Clock hands is an obvious one. So let's say it's 10 past 12. That angle here, and there's also an angle going around the side. And then any orienteering, or in geography, we use it all the time for locating things. Or if you're a sailor is a big one. They use angles all the time. So what is an angle? It just measures how much something has turned. So, and it's measured in degrees. So in this case, O, or 0, would be kind of your origin of the angle, and then you have a line going off here towards A and a line going off B, and this little measurement here, how far it's basically how far A has turned. Think of it as a clock hand. A has turned up to here. That is measured in degrees. That's what an angle is. It measures how much something has turned. Then we have a full revolution. So what would that be? Well, I start here and I go all the way around. Think of your clock hand. So this is starting at 3 o'clock and you're going all the way. Well, it would actually go this way, but besides the point, it goes all the way around and starts where it goes back to the start. Now, how many degrees are in that? Well, you've probably heard it before. 360. Now, this is your magic number that you have to remember. So there's 360 degrees in a full revolution. Or another way to think about it, you notice we've drawn a circle. So this whole circle angle is 360 degrees. And yeah, this is really, really important. You got to remember this, 360. So 360, and this little dot means degrees. Straight angle then. So if I have a straight line, there is actually an angle there. It's here. And there's also an angle on this side. But this angle here, how much is that? Well, think about it. This is half a circle, yeah? It's not the full revolution we were talking about. It's only half of it. So what's half of 360? Well, it's 180. That's how many degrees is in a straight angle. Then again, what about if we have a right angle? So this was a straight angle. What about if we just cut this in half then? How much is in this? So we've cut it again in half. So what would this angle be? Well, it would be 90 degrees. So we're halving each time. We started off with a full revolution. That's 360. Straight line is 180. And then if I do a right angle, so they're kind of perpendicular to each other. That's what perpendicular, you probably heard that before. That means 90 degrees. So we usually indicate it with this little box. Sometimes we don't, but it means 90 degrees. You probably have seen it in lots of places actually. In the corner of a pitch is usually the obvious one. So that angle there, this angle here, is 90 degrees. Why? Think about it, it's a straight line, meets another straight line, and it's not a straight angle, it's half of a straight angle. They're perpendicular to each other, that means they're going to be 90 degrees. Woodwork, carpenters, really, really important. If your chair is not set up properly, you're going to fall off it or it might break. So that angle there, what angle is it going to be? It's going to be 90 degrees. So it's going straight and then boom, straight down. And it's perpendicular, so it's going to be 90 degrees. Then just some other words for different angles. I know there's a lot of information here, so if you feel like pausing just to kind of, or rewinding just to remember things, that's fine. We have 3 different types of angles. Now these are all just names, they're just labels, they don't have any special properties, they're just names. We have an acute angle, which is less than 90 degrees. So think about it, do you remember I had that line going straight up? This is kind of a little bit less rotated, so that's 90 degrees. An obtuse angle is between 90 and 180, so it's greater than 90 degrees. So if I pull this arm down to there, it would be a straight angle, or 180 degrees. But if it's between here and here, we say it's obtuse. So imagine this hand like a clock hand. If I pulled it back down to here, well then it would be less than 90 degrees. It would be an acute angle. Now bear in mind we're measuring the inside bit. We're not measuring this outside angle here. If we were, we'd be looking more at this, the reflex angle. So this is more than 180 degrees. So if I'm looking at this guy, that would be a straight angle about to there, but it keeps on going. So it's more than 180 degrees, and we call that reflex. So these are all names. You just have to remember, acute is like the small guy, obtuse, a little bit bigger, and reflex is this humongous going around more than 180. So yeah, you got to remember these names, and just remember what degree would they be about. So yeah, here's some examples then. So 65 degrees, it's an acute angle. Why? Because it's less than 90. Right angle, 90 degrees. Obtuse, it's 100 degrees would be an example because it's greater than 90. Straight angle, remember it's half of my 360, so it's going to be 180. Now this guy, it's greater than 180, but it's not a full rotation. It's not 360, so this is going to be 255 degrees. And then a full rotation would be 360 degrees. If we're naming the angles, if we wanted to write out, oh, how do I label this angle here? We label it like this. So we have a line, and then we have this little kind of angle sign. So it's like a little kind of crocodile mouth. X, Y, Z, and then line. So I'll break it down. This two lines are kind of like brackets, and they just mean the size of something. This is in geometry in general. This means the two lines just mean the size of something. So the size of, now what's inside? The angle, this just tells you, oh, angle. And how do we read the angle? We read it like this. Start at X, Y, Z. And whatever the middle one is, that's where the angle is located. So this is telling you the size of angle X, Y, Z. So we're looking at this angle here at Y is equal to 65 degrees. How would we do this one? Well, we'd say this line. So the size, your outer two lines of the angle A, O, B, A, O. So we're looking at O is 90 degrees. B is 90 degrees. The last one, size of angle, now remember P, Q, we're looking Q is in the middle, R, or, you notice I did it in the opposite way, I said R, Q, P. You could swap P and R around, or A and B around, doesn't matter. Q has to be in the middle though, that's the most important part. Q has to be in the middle, or O has to be in the middle. The middle label is the important guy, is equal to 180 degrees. Then if we had lines, so line segments to be particular, you just say, you name them by using the endpoints, so A, B, because those are the two endpoints. I could also label it BA, doesn't matter, just need to have the two endpoints. Then if I had a length or a size, what do you think we're going to do? What was the notation we used a minute ago? We have the lines. So straight line, A, B, straight line, so that's your brackets, is equal to 10 units or 10 centimeters or 10 meters, whatever. Okay, I'll give you a minute to do these recap questions. So give an estimate for this angle and write it down obviously. So I just said the size of angle AOB. You could have also wrote BOA. Now I should have wrote equals 80 degrees. So it's not exactly 90 degrees. It's not a right angle, it's acute, but it's nearly a right angle, so I said 80 degrees. What types of lines are in this picture? That's a ray, because you have an endpoint and then it goes off infinitely. And then we have a line segment, because there's two endpoints over at both ends.